Welcome back to the channel, everyone. Today we're going to discuss functions from word problems. We're going to write them based on a word problem. And I'm going to use IXL today because it's a pretty good source that we can use for free. And then make sure that we can actually write these functions and double check our work with immediate feedback. Okay? So if we recall how to actually write functions from any word problem, we take this from its structure. So functions, word problems, equations all have that same structure, generally speaking, where we have our rate times our variable or our unknown plus our constant, and that's going to equal our total. Okay? So if you recall with these, we kind of had a little bit of work with this, and we said, hey, the variable, that's what we don't know, that's what we're solving for, that's our unknown. The constant is something that we could already have or already have done. It could be something, if we're talking about like how far down or up we've gone, okay, so how far we've already traveled, okay, or how far we have yet to travel, okay. So these are little terms that we're kind of looking for here. And then the rate, this is where we look for words like for each, for every, per, etc. All of these imply that we have multiplication here, okay. So based on that structure, I am going to use that to create my function in this case, okay? So what I like to look for first is I like to look for my variable. And in this case with functions, we have two variables that we're looking for. It tells you right here, write your answer as an equation with p first, followed by an equal sign. That's the instruction. So my question is, what does p represent? Well, if I read through here and I find where p actually is, p represents the number of pieces learned. So that's where I'm going to start. Okay? So I'm going to start with p equals the number of pieces learned. Okay? Now I have another variable then too. Okay? The other variable I have is the relationship. This equation shows the relationship between the number of weeks w. That's my second variable. Excuse me. So that's the number of weeks. Okay? So based on this, what I am writing an equation about is I have to figure out which one of these two is actually my total. Which one is it equal to? Well, it actually tells me here. Write the answer as an equation with p first, followed by the equal sign. What that implies is this p is going to be my total over here. Okay, so I'll write this in green. All right? So I'm just going to use the same structure, and then we'll rewrite it in the structure that they want. Okay? Which means then my variable w will come over here. So we're just going to insert it, substitute it in for w, the variable that we don't know. Okay? So that's the first piece. Now I look to my rate and my constant. So I'm looking for those keywords each, for every, and then for the constant, have we already done something? Well, I look up here and it says Kelly already knew how to sing 6 pieces. She already knew that. This right here is your constant. Okay? And then you have to ask yourself, is it a positive or negative 6? Well, if we already know that, we would consider that as a positive 6 pieces that we already knew, okay? It would be different if we were saying, hey, she has yet to learn 6 pieces. Then that would be negative because she hasn't actually accomplished that yet, okay? And then I look for my rate. She expects to learn 2 new pieces during each week. Again, that is implying my rate. My rate then would be 2 times w plus 6 equals p, or in the format that they want up here, p equals 2w plus 6. So that's the first way that we can actually create an equation based off of a word problem.